Chapter 1, Traffic Engineering. 1.1, Introduction and Scope of Traffic Engineering. Definition: Traffic engineering deals with traffic studies, analysis, and engineering application for the improvement of traffic performance on road. Institute of Traffic Engineers define traffic engineering is that phase of engineering which deals with planning, geometric design, and traffic operation of streets and highways, their networks, terminals, orbiting lands, relationship with other modes of transportation for the achievement of safe, efficient, and convenient movement of persons and goods. Necessity: it is a relatively new branch of civil engineering. It became necessary with an increase in traffic volume, traffic congestion, traffic problem and parking problem, environmental degradation, traffic accident has created the attention to the performance characteristics of highway transportation and continuous study and development for better geometric design, capacity, intersection, traffic regulation, signals, sign, road marking, terminals, street lighting, etc. has been recognized as an essential tool in improvement of traffic operation. Objective of traffic engineering: basic objectives of basic objective is to achieve efficient, free and rapid flow of traffic with minimum number of traffic accidents. Traffic engineering includes a variety of engineering and management skills, and the following are the main aspects: traffic characteristics, that is vehicular and road users. Traffic studies and analysis include speed, volume, capacity, traffic patterns, and origin and destination study. Traffic flow characteristics, parking and accident studies. Traffic operation, control and regulation, laws and traffic regulation. Measures, installation of traffic control devices like signs, signals and islands. Planning and analysis include separate phase for expressway, arterial roads, mass transit facilities and parking facilities, etc. Designs include geometric design, traffic facilities, intersection, terminals, lighting. Traffic administration and management includes engineering, education and enforcement, and continual research. Road user characteristics. Road user characteristics are pedestrian, cyclist, car, rickshaw driver and vehicular driver. The various factors which that affects road user characteristics are classified as physical characteristics, mental, psychological and environmental. Physical characteristics. Physical characteristics may be classified as permanent, as temporary and permanent vision. About 90% of information is perceived in visual. Human eye is sensory organ to see and evaluate the size, shape and color of an object and estimate the distance and the speed of the body. Hearing. It is important for pedestrian and cyclist. Relatively defective hearing is not very serious handicap in case of road user. Strength. It is most important for heavy vehicle drivers. Alcoholic drink. It can be measured by the blood alcohol concentration. Standard for different countries varies. For example, 20 mg per 100 ml of blood is available in England, but in case of Nepal, this tolerable is zero tolerance. Accident rate increases after 80 mg per 100 ml of blood. Effect of drugs other than alcohol may affect driver performance. Fatigue reaction. Tired drivers usually suffer from lack of concentration and have long perception time and more likely to commit an error of judgment on the roadway. Illness. Illness may cause physical inability to drive, mental tension, and lack of concentration. B. Mental characteristics. Knowledge, intelligence, skill, experience, and literacy can affect the road user characteristics. Knowledge of vehicular characteristics, traffic behavior, driver practice, rules of road, psychology of road user are helpful for safe driving. Psychological characteristics. Emotional factors such as attractiveness, fear, anger, impatience, distraction, and worries come under these characteristics. Due to these characteristics, road user does not pay attention to traffic regulation and do not have right attitude to the other traffic. D. Environmental factors. Behavior of road users are affected by various environmental conditions as traffic characteristics, traffic flow condition, atmospheric condition, locality of driving and facility to the traffic, etc. Characteristics of vehicle. Vehicular characteristics are important for highway design and traffic performance. Traffic characteristics are classified into static characteristics, vehicle kinematics, and dynamic characteristics. Static characteristics. The height of the vehicle affects the clearance needed on the structures like overhead bridges. The height of driver's seats affect the visible distance. Headlight height affect the sight distance at valley curve for night driving. Clearance below chassis will limit driveway vertical profile, humps and dips. Vehicle widths affect the minimum width of traffic lane, shoulder and parking facilities. Length of vehicles affect the capacity, maneuverability and overtaking distance. Minimum turning angle will affect the design of sharp curves for maneuvering at low speed. The weight of the loaded vehicle will affect the structural design of pavement and cross-train structure. Maximum vehicle dimension as per Nepal road standard as all vehicle width 2.5 meter and the design height of the maximum height of the design vehicle is 4.75 meter, length 18 meter, single unit bus 12 meter, weight of loaded vehicles. Single unit truck maximum gross weight equal to 12 tons. Single unit truck rear axle dual tire 16 tons. And as per Indian road standard, the maximum dimension of the vehicle is as shown. Vehicle kinematics. The fundamental relationship between force and acceleration is given by F equal to ma. The vehicle kinematics can be classified into two categories, that is for uniform acceleration and for non-uniform acceleration. For uniform acceleration, the speed acceleration function is given as shown in the slide. Similarly, for the distance time function and distance speed function is as shown in slide, where a equals to acceleration, v speed, v naught equal to initial speed, x is the distance and t is the time period. And second category is for non-uniform acceleration. Special case, that is the acceleration varies inversely proportional to speed, that is dv by dt equals to alpha minus beta v. And for non-uniform acceleration, the relation between speed and time and velocity, and acceleration and time relation is shown in figure or slide. Example 1. An impatient car driver stuck behind a slow moving or slow traveling at 32 kilometers per hour decided to overtake the truck. The accelerating characteristics of car is given by dv by dt equals to 1 minus 0.04 v, where v is the speed in meter per second and t is the time period in second. Now calculate what is the maximum speed attainable by the car, what is the acceleration after 2, 3, 20 and 200 seconds, when will be the acceleration of a car approaches to zero, how far will the car travel in 200 seconds. Solution. A. Acceleration A will be maximum when the initial velocity is zero, that is the when a vehicle starts from rest to motion, the acceleration will be maximum. Then for A max equals to dv by dt equals to alpha minus v into alpha into v, that is v equals to 0, therefore A max equals to A. Also for maximum speed, dv by dt, first differential equation for the velocity is equals to 0, that is dv by dt equals to 0, and solving these equations, v maximum that can be attainable by the vehicle equals to alpha by beta. Now comparing the equation dv by dt equals to 1 minus 0.04 v, we get alpha equals 1 and beta equals 0.04. Now maximum attainable acceleration of a vehicle is equals to A max equals to alpha, that is 1 meter per square second. Acceleration time relationship. The relation between acceleration and time can be simplified as shown in slide. And for the different time period, that is 2, 3, 10 and 200 seconds, the accelerations can be calculated from the simplified equation. See, acceleration time relation. The simplified equation for the acceleration is calculated as in previous slide. And from previous solution, at time period t equals 200 seconds, A tends to 0 meter per square second. That's why we can conclude that after 300 seconds the accelerations will be 0. Or by solving this equation, we are putting the value of A equals to 0, we can determine the time period when will be the acceleration equals to 0. Distance time relation. The distance time relation is shown in as in slide, where alpha equal to 1, beta equal to 0.04 and v initial v naught equals to 0.278 into 32 km per hour, that is equals to 8.87 meter per second. Then the distance traveled in 200 seconds is calculated from the equation and is calculated as 7.1 kilometer. Dynamic characteristics. Dynamic characteristics of vehicle affecting the road design are speed, acceleration and braking characteristics. Speed of the vehicle affect side distance, super elevation, length of transition curve, limiting radius on horizontal curve, length of transition curve on vertical valley curve and on humps, width of pavement, capacity of traffic lanes and design and control measures on intersection. Power of the vehicle. Power of the heaviest vehicle and its gross weight govern the permissible and limiting value of gradient on roads. Braking characteristics. The deceleration and braking characteristics of vehicle depend on the types and depend on design and types of braking system, that is mechanical, fluid or air brake and its efficiency. Braking test. At least two of the following three measurements are needed during the braking test in order to determine the skid resistance of the pavement. That is braking distance, that is braking length, initial velocity, actual duration of brake application, etc. Example 2. A vehicle hits a bridge abutment at a speed estimated by an investigator as 15 km/h. Skid mark of 20 meter on the pavement, that is a coefficient of friction equals to 0.35, followed by skid mark of 60 meter on a gravel shoulder, that is coefficient of friction is taken as 0.5. Approaching to the abutment are observed. If the speed limit is 80 km/h, is the driver overspeeding? And this is the straight section of road, and there is a bridge and an abutment. This is the location of the vehicle where the driver applies the brakes and hits the abutment. In this case, this is the initial position where the vehicle starts to apply brake, and at the time the velocity is taken as v0, and then skid on the pavement surface and mark a skid mark of 20 meter, and the final velocity when the vehicle enters the shoulder is taken as v1. Then after the skid on the pavement, the vehicle again skid to the shoulder and hits the abutment at a velocity of v2, that is the 15 km/h equals to 14.17 meter per second. That is a skid mark on the shoulder equals to 60 meter and coefficient of friction equals to 0.5. And for the solution of these cases, we start from the case 2. That is, for the case 2, skid distance is equals to v1 square minus v2 square by twice gf, and calculating these equations we can calculate the velocity. v1 is equals to 24.62 meter, and for the first case, applying the same equation, the initial velocity v0 is calculated at 27.267 meter per second and is equals to 98.16 km/h. Since the v0 is greater than 80 km/h, the vehicle is over speeding. Please like, share and subscribe for more lecture, tutorial and solution. Thank you.